before at the end of the last video, I actually said that we talk about measures of dispersion or how things are distributed. But before I go there, I realize that I have more to talk about, especially the mean. And before I do that, I want to differentiate between a sample and a population. A sample and a population. And I touched on this a little bit in the last video. Let's say I wanted to know, I don't know, let's say I want to know the average height of all men in America, right? So let me make the set of all men in America. So that's all men in America. I don't know, there's 300 million people in the US, and half of them maybe roughly are men. So this would be 150 million men. Right? And it would be nearly impossible, even if I was intent on doing it, to actually measure the average height of every man in America. Frankly, every few seconds, one of these men is being born and one of these men is dying. So, by the time I'm done measuring everything, someone would have died and some new men would have been born. So it would almost be impossible. And if not impossible, it would be very tiresome to measure this the average or the mean or the median or the mode of this entire population, right? So the best way I can get a sense of this, because I'm interested in what the average of the population is maybe I can take the average of a sample. So what I could do is I could go up to, and I try to be pretty random about it. I don't want to hopefully my sample wouldn't be my college's basketball team, because that would be a skewed sample. But I try to find random people in random situations where it wouldn't be skewed based on height. And I maybe collect 10 heights, and I get, well, maybe even, the more people I get, the more indicative it is. But if I got 10 heights, and those 10 heights were, I don't know, I'll do it in 5 feet, 6 feet, 5.5 feet, 5.75 feet, and, well, let's say I only do 6, or let's see, and 6.5 feet, right? Those are the 5 people that I sample, and we could talk more about what's a good way to generate a random sample from a population so it's not skewed one way or the other. But anyway, if I wanted to get a sense of it, and if I was kind of lazy, so I only took 5 measurements, this is the way I would do it, and this would be a sample. This would be a sample of the population. So instead of taking the mean, let's say that's how I wanted to calculate the average, by taking the arithmetic mean. Instead of taking the arithmetic mean of this entire group of 150 million people, I might just be happy taking the mean of this sample, and that'll be called the sample mean. And I want to introduce you to some notation, even though it's kind of so in statistics speak, the mean, this mu, it's a Greek letter, essentially the Greek letter that later turns into m, but mu is the population mean, and this is just a convention, population mean, and x with a line over it, that is equal to a sample mean. Sample mean. And these are just notations that people might see, and you might have been confused if sometimes you see something, people talk about means, and you see this mu, and sometimes you see this x with a line over it. And it's nice to know the distinction. Here they're talking about the mean of a sample of the population, and here they're talking about the mean of the population as a whole. Now, the way you calculate them is essentially the same. If you want to figure out the population mean, you'd go to all 150 million people at one moment, and add up all their heights and divide by 150 million to get the population mean. The sample mean, you just add up the numbers in your sample and divide by the number of data points you have. And the formulas, and I want to show you, I think it's kind of, how to calculate averages. It's a fairly straightforward operation. And I want to show you how it's often written in statistics books so that you're not intimidated when you see it. The population mean, they'll write it as, so just so you know the convention, each member of a, well, let me do the sample first. Each member of a sample, say this is the first sample, they'll call that x sub 1. They'll call this one x sub 2. They'll call this one x sub 3, x sub 4, and then this one x sub 5, right? And this is just a way of referring to each of the samples. So on a sample mean, they'll say, do you know what you do? You take the sum of these numbers. And you know how to do that, but the fancy way of writing it is to say, let's write a capital sigma, that means the sum. Sum of every x sub n, right? Take the sum of each of these numbers, right? This is x sub 1, x sub 2, where n goes from 1 to, you could say to the size of the population, sometimes, in this case it would be 5, or sometimes they'd write an n like that, and you divide it by the number of members there are in that population. So divided by n. And then, so this is, when you see this in a book, you're like, wow, this is advanced mathematics. But essentially, they're saying take the sum of all the data points, so just sum up these numbers, and divide by the number of numbers there are. So this would just be 5 plus 6 plus 5.5 plus 5.75 plus 6.5 divided by 5. That's all this is telling you. For the population mean, it's the same thing. They just use a slightly different notation. They'll say that's equal to the sum from n is equal to 1 to a big N. And I'll explain why they write a big N of each data point in the population, not just the sample. All of that divided by big N. And this is just a way of, when they write big N, they mean 150 million. They mean, we want you to get every data point in the entire population. So that's what they mean by, and then divide by the number of the entire population. While with small n, it's just the convention, the notation that they say, hey, we just want you to get some smaller number, not the entire population. But the way you calculate them is they're essentially equivalent. Anyway, I wanted to leave you with that just because this is something that if you don't get it clarified early on, it's a fairly simple concept. Later on, it becomes very confusing when people want to differentiate between the population and the sample mean, and you see these formulas written slightly different. Sometimes you'll see a mu, and sometimes you'll see an x with a line over it for the sample mean. Anyway, I'll see you in the next video.